good. Okay, what's the absolute value of 7? What's the absolute value of negative 5? Good. What's the absolute value of negative 3 plus 2? No. So just like regular brackets, we simplify inside first before applying the absolute value. So that would actually be 1. So what's the last one then? Yeah, 2 minus 8 or negative 6. Because only the negative 2 is inside the absolute value. So that's the only one that comes positive. All right, all of these we're going to compare to the graph of y equals absolute value of x. The absolute value of x, we're going to just draw a rough sketch. Okay? This is the absolute value of x. Okay, we're gonna graph these functions and compare it to y equals absolute value of x. I probably did not draw that perfectly. It should be a slope of 1 and a y-intercept of 0, or slope of 1 and negative 1. But generally speaking, you're going to get the idea. When we graph this, I want to do this pretty quickly. Someone's phone's vibrating. So if we're comparing y equals the absolute value of x to y equals the absolute value, so math number, absolute value, x plus 2. You could just, well, yes, you do. Okay, what happens? I'm going to actually make y equals absolute value of x in bold, and you tell me what transformation just happened. 2 to the left. So at 2, and it moved 2 to the left. Does anyone remember? So math 30-1, I would say, like, well, your very first unit is on transformations. You do a full unit on transformations, and then transformations, Jacob. Go away. Thank you. Transformations carries through into every single unit. So it's almost like you're doing transformations all through 30-1, this idea of transforming a function. So we would call this, did it move horizontally or vertically? So it would be a horizontal translation. I can't spell. To left. So so notice that the plus 2 is inside the absolute value, okay? And so we think of it as it's actually with the x. And so that's why it's a horizontal translation, because the plus 2 is inside with the x, so it's being applied to the x. Now notice this very next one we're going to do. I'm going to now do the plus 2 is no longer inside the absolute value. It's not with the x. It's outside. We think of it as with the y. And what happened? It went up 2. So it was a vertical or horizontal? Vertical translation or shift, you could also think of it as. To what direction? Up. Okay? Very interesting. Notice that when it was with the x, the plus 2, we moved what direction? Left. But y, when it was plus 2, up. Okay, let's try another one. So let's take a guess. What do you think will happen with this next one? Is it applying to the x or the y? The x, so it's going to be a horizontal. Yes. To right. Okay, so if we graph that 2 to the right, it'll be like that. Okay? And this last one, is that with the x or would we think of it as with the y? Y. So that would be a vertical translation to, 2 down. So y cover a whole unit on this. So a very basic explanation is when it's in this form of y equals, I don't know how much in depth I want to go. X basically does the opposite, and y does what you see. So when we had plus 2, with the x it went left, minus 2 went right. Whereas y, plus 2 up. And really the reason why, it's actually, I don't know how much I want to go depth, I don't want to confuse you too much. But, well, really quickly, if this is plus 2, if I move it to the other side, right, this becomes y minus 2. And so then it's doing the same type of properties. When it's with the y, it's going to go up 2, it's opposite. When it's with the x, it's opposite. I think I might be confusing you more. So this is y plus 2, right? So now it's going 2 to down. So it's always with the variable, it's going to do the opposite when we're comparing it.
Okay, that's all I want to know. With the variable.
Yeah. All right. Blah, 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 blah. Let's go straight to extraneous roots. So with absolute values, guess what? We have extraneous values. I should call them values, not roots, because we're not dealing with square roots. So we may have extraneous values. And how do we know if something is extraneous? By checking the solutions. Okay, so we, just like with radicals, we have to do a check to see if things are extraneous. So extraneous means that algebraically it worked out and gave you a solution, but when you check it, it doesn't actually work. Remember that? So we always reject anything extraneous. So just like radicals, if I'm asking you to algebraically solve an absolute value equation, you have to check to get full credit. Even if I don't ask you to check, you have to check, always. Then you're going to lose marks. Okay? So how do we algebraically solve an absolute value? Well, the steps are so similar. General steps are very similar to that of a radical. We always need to isolate the absolute value. Just like we did when we read radicals, we isolated the radical first. Okay? But our next step is a little different. Because absolute values have two cases, the positive case and the negative case, right? Absolute value, if I said absolute value of x equals 5, what are the two possible answers? The positive case and the negative case. So we actually have to solve both cases. Okay? So in the first one, the first step is done for us. Isolate the radical, that's done already. Now we can go straight to the two cases. So case 1 or case positive, we'll do first. So if x plus 3 is positive, do we need the absolute values? No, we could just drop them. It's equivalent. So the positive case is in the case where x plus 3 is greater than or equal to 0. It's positive. So we don't need the absolute value symbols. So what does x have to equal then? Yes. Good. X equals 2, because we subtract 3 to both sides. Isolate x. So then we have the negative case. And that happens if x plus 3 is less than 0. Right? If x plus 3 is less than 0, or a negative value, how do I turn it into a positive? Multiply it by a negative. So it's equivalent to the absolute value if I multiply it by the negative. Okay, how do I solve for x here? Sure, multiply -1 to distributive property. Negative x and minus 3 equals 5. Plus 3. Negative x equals 8. Switch the signs or divide by negative 1. X equals negative 8. Can we confidently say those are our solutions? Yep. You have to check for extraneous. You can't be confident, even though it's very exciting getting the answers and wanting to move on because you feel complete. You're not complete. It's not complete. Okay, so you have to check both. So the first one, does the absolute value of 2 plus 3 equal 5? Yeah, 5 equals 5. Okay, does the absolute value of negative 8 plus 3 equal 5? Yep, it does. So, in this case, were there any extraneous? No. X is equal to 2 and negative 8. We write a conclusion. There it is. Isn't it nice to be doing algebraic things again? What? You like it? You didn't like it? Yeah, it's more abstract, that's why. This is more concrete, I feel. Okay. Algebraic. So is the absolute isolated? Yes, absolutely. So we do the positive case. Assuming x plus minus 1 is greater than 0, we can just drop the absolute value. Okay. Now what? Sure, you can move the 1 over if you want. I get x equals x plus 2. X minus x, what does that equal? That equals 0. Does 0 equal 2? No. So there's no solution here. Are we done? No, we have to check which case. Negative case. So if x minus 1 is less than 0, we multiply it by negative 1, and then that would give us positive. Okay, distributive property. Now what? What? Minus 1? Which one? Sure, I get, that's fine. It's okay, it's okay. Negative x equals x. Now what? Okay, let's put. Wait, that's not right. That's not right. That's not right. What do you mean? It doesn't matter, because if I have a plus x, I'm going to subtract x. I have negative 2x equals 0. So what does x equal? 0. Looks confusing, I know. That one especially. Is this true? Absolute value of negative 1 is positive 1, which equals 1. That's a really ugly one, hey? It's like so simple that it's hard. Are you ready to try one on your own? No? Okay, together. So, first step, isolate the absolute. Are we good to go? Yes, so we can go straight to case positive. Meaning that x minus 3 is positive. Meaning, do we need the absolute value? No. If it's positive, it's comes out as the same identical thing. X is equal to -3. The negative case is that if x minus 3 is less than 0, if it's a negative value, how do we make it equivalent to the positive absolute value? Negative times x minus 3. So distributive property, now what? Plus x. Get at 3 equals 3x. So x is 1. Are we done? Check. Does the absolute value of -6 equal -6? What is the absolute value of -6? 6. Is that true? No, that is not true. So guess what? -3 is extraneous. And now you check with x equals 1. 1 minus 3, does that equal 2 times 1? Well, 1 minus 3 is -2. What's the absolute value of -2? 2. So our only answer is x is equal to 1. Are you now ready to try? Okay. Try number 4. Check that you have the same thing. Okay? So it doesn't always have to be a beautiful integer as your answer. It could be a rational number, like -12/7. Okay? Now, if this is a multiple choice question, there's another way to check your work. And that is graphically. But you know what? I'm going to jump back to that later. Yeah, you could do that. Or if it's numeric response, though. How about that? Then you're not so lucky. I'm going to come back. Well, let's actually do this. So another way you can actually solve this, especially if this is a numeric response question or if you're checking your work, is graphically. And it's very simple. All we have to do is make the left side of our equation y1 and the right side y2. And then we're going to find something special. Yeah, we did with radicals. Same idea. You could even do it with rational expressions, but I don't really show you rational expressions because they're so ugly to type in that you're more likely to make a mistake typing it in than just trying to solve it yourself. Oh, it would. Yeah, rational expressions are so ugly because there's all these asymptotes and yeah, it's just ugly. Ugly. Okay, math, number, absolute value, 7x minus 1. Now here's the great thing about a graphical solution. It will never give you the extraneous. Now that could be good or bad because sometimes I love to ask for the extraneous, especially in a numerical response. I'll say the extraneous solution is, and then you have to find it. You have to solve it algebraically because graphically it will not come up. That's a good way to ensure that I know that you're solving it algebraically. But for those questions that you're just looking for a quick solution to, you can solve it graphically. Left side or y1 is y1. The right side of the equation is y2. We push graph, and then what are we looking for? You're going to have to zoom out in this one. Zoom 3, enter. So what point is important here? The intersecting point. Oops, let's try drawing that again. So this graph looks something like this, just really quickly, right? We want to find these intersection points. And we find those. How do we find those on our graphing calculator? Second trace, number 5. Now, there's 2 intersection points, so you have to scroll to the one you want and then push enter 3 times. Okay, notice it gave me x as negative 1.71. Well, that's not good for me. Remember, your calculator automatically stores that x. So if I quit out of here, I can go x, math, enter, enter, and there is negative 12 over 7. It automatically stores it once you find the intersection. Okay, and then graph, we need the other one, second trace 5. Scroll over to the other intersection point, enter, 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 and there it is, x equals 2. Notice we just want the x value. That's what we're solving for. Okay, pretty cool? Maybe, maybe not. Let's skip 5 and 6. We're going to come back to 7. Let's look at number 8 and 9. And then we're coming back. We'll go backwards after. So skip all the way to number 8. We are going to solve 8 and 9 algebraically. I'm going to do 8. You're going to do 9. What do we do? Isolate the absolute value. Okay, you can go ahead and do that. Get the absolute value by itself. Gurpreet, what would you do first if it was you? Nope. -1. I know. Okay, then what? Divide by 2. All of a sudden my 1's always get exaggerated. So used to drawing absolute values. So once you've done that, can you now do the positive and negative case? Yes. Okay. So before we can do our positive and negative case, we need to get our absolute value isolated because, yeah, we need to. It's pretty ugly otherwise. I apologize in advance. This is not very beautiful answers. Okay, once you get your solutions, are you done? Yeah, you wish. You gotta check. And you always check with the original. Do not go back to the one that you isolated the absolute value, because what if you made a mistake there? So we always check with original. Another thing about a check that's really important is you can never move things from left side to the right side of the equation. We're trying to prove that left equals right, so we can't move things. When you multiply 7 by 6 over 7, what does that equal? 6. Yeah, the 7's cancel. Okay, once you're finished copying down that one, which should be pretty straightforward. The fractions are pretty ugly, but that's about it. Can you try the next one? Number 9. Try 9. Okay. Is there any questions about number 9? Did it go okay? Yeah? Good? Okay. So I'm probably going to skip the ones on the other page and just go straight to this. If I want to solve this graphically, how would I set it up? Y1 as the left side, Y2 is the right side. Now, if Y2 is equal to 33, you're probably going to, have to zoom out. Okay? Y1. Okay. Can I type it in now?
Okay, yeah. Oh, I thought you were ahead of us. Never mind.
Oh, okay. So type that in.
Oh, wait, no, never mind.
Am I? Okay, so if you're typing this in with the other calculator, it'll like the older version on the software, it'll say ABS. So your Y1 would be ABS bracket x minus 5 plus, you'd have to go ABS bracket 6x plus 2. Okay, so depending on your version of software on your calculator, hopefully yours it makes the bars for you because it looks way nicer than ABS, but depending on your version. Yeah. Okay, you push math, number, so go right arrow over to number 1. Got it? And then, yeah, you can click the arrow to get out of it. Have to be able to type it in order to solve it graphically, right? So that's why we practice this in class. Okay, so you have to push the arrow. Oh, right arrow. To get out of it. And then, yeah, no, X. 6X. So you don't have to close it. Okay. So if it gives you the vertical bars, you don't actually have to close it, because if you just go over and type in inside what goes inside, it already has the open and the close bracket for you. If you have the old version, like this, and that's what it looks like, then you would have to put the brackets closed. Only if you have that version. Okay, now if you have regular windows, you're going to see this. Whole lot of nothing. Okay? Because we want when y equals 33. That's way up there. So we can manually change our windows, or you can zoom out. If I manually change my windows, I would probably just change my y max to like 50. Because I know I need y2 equals 33. So if I go, okay, I'll just change my maximum y to 50 and see if that works. And it does. Okay, so my windows, all I did was x min, x max. Actually, I'll just write it like this. So x was still negative 10 to 10, scale of 1. And y, I did negative 10 to 50, scale of 1. Okay. And your graph should look something like that. It's kind of a funny looking graph. It has this like jump, in it. Something like that. Cool function, actually. Okay. And we have to find what? Intersection. Okay, second trace 5. So scroll over to the one you want. You'll have to do this 2 separate times. And then once you're at the one you want, enter, enter, enter. Now, if we want that as a fraction, what do we do? So quit x, math, enter, enter, negative 30 over 7. Okay, and the other one, second trace 5. Scroll over to the other intersection. Okay, again, do we like that x value? Can we make it nicer? Yeah. X, math, enter, enter, it is 36 over 7. You do not have to worry about extraneous solutions. There will not be any. Yeah, like the calculator doesn't give you any extraneous solutions. Only algebraically that happens. Okay? All right, I'd like you to try 2, and then we'll call it a day. Second trace 5, and then you scroll to the one you want and just push it 3 times. 1, 2, 3.
So you can only do it here too, right?
Yeah, the 2 intersection points. Yeah. Okay, so once you get it, go quit out back to the regular calculator menu. Go X, type X, math, enter, enter. Well, negative 1 is an integer. It's good. No, I didn't. This is my y1, y2. I haven't solved it yet. So, second trace 5, enter, enter, enter. Negative 1. Other one. I think it's 7.3 repeating. Okay. Oh. I have to go way over. Of the line. Okay. Like over here. There you go. Okay, so 7.3 repeating, you'd want to change that to a fraction. So I'd quit out of here. X. Math, enter, enter. You should have had 22 over 3. And negative 1. Right? Oh man, that was a long lesson. I'm sorry, guys.
Oh wow. I didn't realize how long it was.
Me neither. Okay, the assignment is. This is the wrong one. Don't do that one. Not 336. Let's try this again. Page 389. So tomorrow, guys, it's not going to be much different. The only difference is we're going to solve algebraically, solve when it's quadratics instead of linear. Absolute values. No, you know what? Before I go home, I'll try and upload them. Okay? So they'll be up tonight. Okay, I'm sorry. I had 2 family birthdays this week, like my immediate family birthdays, and so life was a gong show. And I forgot to take them home. Okay, so make sure you do this homework, guys. It doesn't, like, even though it might seem easy, forget it if you don't practice it, right? Practice, practice. And then Wednesday is a quiz. And it will include today's lesson, tomorrow's lesson, and the first 2 lessons, the piecewise stuff. Okay? This Wednesday. Tomorrow when? When? Morning should be fine. Yeah. I should be here anytime, like by 7:45 I'll be here. Yeah. Right. When do you leave? You're gone all day? You gone all day? 1 second. I'm gonna stop the video.